Hi everyone, I'm back. So today we're going to talk about some shenanigans that I found during my work as a penetration tester. It will be, the whole idea of this talk, I have to say before we start, was that I was supposed to present a really cool attack chain in authentication provider that uses authentication for banks. The banks buy this SaaS service and get sort of a template for authentication. And they use that and you install that in your environment and all kinds of shit goes down, full cluster breakout. But then I started to investigate all the coding examples for the actual exploits. And if you have a little bit of Google foo, you would be able to determine that company pretty fast. So I shifted the post-exploitation phase a little bit. But so who am I? My name is Jesper. I'm a freelance penetration tester. I work with offensive security for a German hacker community called Cure53. I only do penetration tests. I don't fix anything. I just break stuff and leave, basically. So I'm a glorified author. That's why I test a lot of pens, right? I also do SecurityFest with a bunch of people. They're not really here yet, I think. And I do Säkerhetspodcasten, which I hope someone heard. Otherwise, I'm sad. How many have listened to it? Oh, shit. I'm famous. And then I did Hackad with a colleague of mine, Linus. I think he's here somewhere in the audience. There he is. Look at him. He's pretty. And David, Ginny as well. It was a lot of fun. Very good that it was a bunch of adults doing that with us. Otherwise, it hadn't become a TV show at all because it was there were things everywhere. So some legalese before we start. This presentation is based out of things that I've found during active engagement. So some of the stuff in here is a bit unorganized and out of bounds, if you can follow along all the way. And that's just the way things are. So let's move on. So today we're going to look at a large repository of 250,000 lines of code. No. That's not what we're going to do. We're going to embark on an adventure. And this adventure is about the web application horse that lives in the Kubernetes fortress of Doom, which has sort of a loosely attached bond to the SaaS authentication service in the cloud, which lives within a cloud, right? So in order for this to be a proper adventure, we need to have a treasure map, right? Everyone is very quiet, right? Of course, of course. So we have a treasure map. Boom! So the goal for this exercise is we have to sort of convince the mighty web application horse to give us an entryway through the Kubernetes fortress in order to reach the workload village. Because in the workload village, there's a party going on all the time, which is amazing, right? And after we're in the workload village, we need to catch the ferry that crosses the sea of unbreached clusters in order to get to the treasure at the top where we breach the cluster and find the gold. Sounds good, eh? And we have not very much minutes to do this, so it's going to be a bit of a rapid thing, and it's going to be a lot of details. Just go along, and we can talk about it later, because, this will be it. So the gist of the whole exercise is to find some kind of exploit within the web application horse, travel within that reverse Trojan horse thingamajig, inside of the ingress, into the Kubernetes, into the pod, from the pod, break the cluster itself. Anyone who is uncertain about the goal is, raise her hand now. This is awesome. That was it. Nope. So the whole idea of this application is that we have a web application, and that one is provided by a SaaS provider that gives you basically a web application with a UI that you can log into and create your logging entries. Like you want to have like SAML, you want to use GVT, you want to do OAuth, you have to have a fancy WebAuthn endpoint. You need all the bells and whistles, right? And that's complicated and takes a lot of time. So no one has time for that, so they invented a project which you implement in your cluster, and then you can build dashboards, and you can do all kinds of shenanigans, and you just have to sort of verify that one token is actually coming from the right sort of SaaS provider in order to get an authentication schema into the backend. That was a lot of information in a short while. Basically, log in, validate, welcome to the application. But it's customizable, so me as a client can change the icons and add some nice CSS and all kinds of cool things. Very secure, obviously, right? So we get this, and when I do penetration tests, I only do code-assisted penetration tests, so I have the full source code. Otherwise, they will spend a lot of money for me to just find one hole. So I always get code-assisted penetration tests, so I know what I'm looking for. So I start to dig in to the code and look for stuff, and the basic thing I tend to look at in terms of Kubernetes stuff is user controllable objects or something that get executed by user controllable input. Makes sense, right? So after a little bit of a digging, we found out that the web application has a bunch of values that can be set by the user itself in order to customize the user experience. And that is done using Java EL expressions, basically. And those are validated through a process that is coded in a class, etc. A lot of people is nodding their head. Yes, there will be a classic web vulnerability in this one. Nothing has ever happened with user-controlled EL objects, right? So I'm just going to go right for it. So this is the thing we found. We found a class called password eval, which get executed in your pod in the backend, which is awesome. In the backend in the pod. And show of hands here, how many in here think that the pod is running like Alpine or something? No one? 1, 2, 3, it's running Alpine, of course it's running Alpine. So this gets executed, and anyone here sort of feels what's going on here in this little code example? What could possibly happen here? You don't have to tell me. But what if, we can talk about a little bit about expression language injection thingamajig. So it's basically used in order to, in this sense, it's like controlling the sort of payload that gets sent back and forth. And it's done that by calling a bunch of stuff, basically, in order to change, in order to sort of fit into the application that we're attacking. So this function, armed with the class that we found in the repository, could give us something like this, right? So in this example, we just give them a URL, and then we sort of call the function, and that function we're able to break out of and do curl, basically. And that could be like your collaborator payload and whatnot. So this was sort of the initial bug. The funny thing is with this that I can't really tell you here is that, but I'm doing it anyways, but not in detail, is that this was actually within OAuth payload field. So it's sort of obfuscated all the way to the backend, and then it sort of gets executed. It was really funny in this simple example. So if we're taking this sort of attack payload a little bit further, this could happen. And this is amazing, because this is when the talk begins. So what we're doing now is that we're actually using this EL expression in order to get a reverse shell back to the mothership. And what happens at the motherships? No one? Why do you use Netcat? Come on. No? Okay, you use Netcat in order to get a shell, obviously, right? So then we get a shell, which is pretty cool, right? So now we are the authentication provider, and of course we haven't hardened our deployment, so now we're roots within a pod, within a Kubernetes cluster, laying somewhere on the internet we don't know nothing about. And this is where the fun happens. So this is sort of my specialty. Like, I am the guy who really thrives within remote code execution and server-side request forgery. That's like my whole tea, right? And my sort of focus of interest is within the cloud realm. So getting a server-side request forgery that I can sort of control, or remote code execution with a shell in this case, is awesome. So so that everyone is on the right term, we have to do a quick recap, right? So what happened? So we found some kind of vulnerability in the web application that is internet facing, which sort of led us here, right? So now we're inside of a web application. We have a shell within a pod. And now what? So how many in here are like running Kubernetes clusters or are responsible for securing Kubernetes clusters? 1, 2, 3, a few, not many. How many in here know what Kubernetes is? Good. Otherwise, we would have a big problem. And I guess a lot of people here use cloud services as well, right? Show of hands. Everyone, right? Dumb question. Okay. So we exploited the vulnerability in the web context, which is awesome. That is a cool find. It will be a critical in my book, and I get more pay, and everything is nice. But now the adventure really starts, because now we want to take over things, right? And now the shenanigans starts. So post-exploitation. We made a hole in the wall, and now it's time to reap the benefits. And you do that with tools, right? And I'm sorry to say that the tools I'm going to show you now are native cloud tools and curl, so it won't be that funny. It is automatable. Yeah, I will give you some one-liners, and you will see a bunch of curl requests from this point on, and there will be a bunch of details. But you don't have to be quick to sort of write it down or do anything. Everything will be posted in a Git repo that you will get the link for in the end, so you can sort of play with this around. Some of the stuff that I'm going to show you now is not, it's like a default, insecure default in cloud environments. So yeah, go bananas. So when we get access to a pod, in this case with root user, we have the ability to do whatever within the pod, right? And since it's Alpine, we do have a bunch of library binaries already in there. Like vget and curl are like the Swiss Army knife of the internet, right? You can do anything with curl. So in this case, we download the tools for the said vendor. So we know that the vendor, for example, is AWS. Then we can download the AWS CLI in order to talk to API endpoints from within the pod. And we already know that it allows egress traffic because we have a reverse shell. So the pod has already connected out to the internet to our machine. So we know that we have internet capabilities. Well, we don't know that we have DNS, but we are able to call out, which is woohoo, good. So we will be able to download tools, and we will be able to set execution bits on the binaries locally because we're root, right? And then like rootless containers and distroless containers and security context and whatnot, they could apply, and that will sort of give us a little bit of a road bump. But basically what we do is that when we get the sort of foothold, we can install the package manager, we can install BusyBox, we can install curl perhaps. We might be able to find some deb repository that we can curl from or whatever, right? So we are able to sort of install stuff. And what I tend to do is I start with kube control in this case, which is the Kubernetes command line interface where all the ninjas live, which is really versatile in this case. So first off, we install some tools in order for us to communicate with internal systems, in this case, control plane stuff. So far, everyone is with me, right? We're off to a good start, because it will go south from here. Default service tokens, or default service account tokens, is something natively enabled in Kubernetes, and it's deployed everywhere, basically. And that is a read-all token that could list unauthenticated endpoints, get information about the cluster, get sort of notion on what's going on and what's happening within the cluster. And those should never, ever be appended any rights to do anything else. Anyone here has seen this happen before? That someone might have put some kind of credentials or set of permissions to the default service token within a namespace? That is terrible, because that is available everywhere. And that should not be the case. Then it will make it very, very easy for an attacker to do this, for example. And in this case, you get a list of all the secrets within the namespace admin test1, and then you're able to use those said secrets to do whatever, right? You can decode them, you can use them, it could be anything. It's okay to use the secrets with static keys and whatnot, but you sort of need to protect where they begin and when they start. This is basic stuff, but no one really cares about this. I think it's important to address that this is a minimal change. Never append extended permissions to default service account token. And in addition to this, you don't really need a default service account token ever. So you shouldn't mount it altogether. You don't need it, but it's there by default. So remove that one. That would be a good thing, I guess. Yes. And then we have something else, which is pretty funny. I'm just doing this in order to, guys, so you can sort of follow along later on here. It will all make sense. So configuration maps, config maps, it's basically place within the Kubernetes cluster where you could put things that's going to be reused, like build me an Nginx, or pop up me a node thing, or get me a traffic ingress controller, or whatever, right? So it's basically resource verb that could be used to store configuration data, and it should never, ever, ever be used to store credentials. Guess what? All of a sudden, there is credentials there because people map their production templates straight into the config maps, which is not intended for it. It says so in the caution here is taken from the manual, and then you have all your production secrets within the config maps, and guess what? They're readable by everyone. So if you're lucky, you're able to sort of just do a kube control query in order to get all the configs maps. And this is an actual example from a production environment that we did this for. And yeah, then you have the cluster breakout here because you have all the access credentials within the configuration map, and that is readable for everyone within the namespace and whatnot, which is really bad. And then we have the fun things. Cluster control planes, right? So in order to get all this shenanigan to work, I can move this over here maybe. We need to have a control plane, right? And that is something that sort of orchestrates the whole, the whole symphony of Kubernetes, right? So that in the control plane we have the single point of truth, like dictating what's going on. If we're going to scale up, if we're going to scale down, and if we're going to put more resources in the hacked web horse, or if you're going to pull down resources for the hacked web horse and whatnot. So it sort of dictates what's going on in the cluster. If we want to build more pods or more workloads, add stuff, remove stuff, the control plane will be sort of the point to query in order to get this to happen. And that is nice. And we can use that to our benefit. So we have a reverse shell with root access within a pod. We have determined that. But that's not fun, because we're only in a pod, right? What we're going to do? Mine crypto, maybe. If they have like good resource quotas, we may be able to get like a lot of working power for our advantage. But that will not really be the case, right? It's really boring. So what we want to do is that we want to privilege escalate. We want to do things. And this little technique called node impression is the most awesome thing ever. This will be an example from the Google Cloud now. So we're going to shift clouds back and forward now for the one who's not already falling asleep. That will happen. So in this case, we will use Google as the example. So in this case, a Kubernetes cluster, a GKA workload, guess what? It's a Kubernetes cluster within a Kubernetes cluster running in Google. Holy pa-pam, right? So in order for us to sort of scale up our own cluster, we will, the nodes or the master nodes or our Kubernetes cluster needs to tell the backend that, hey, we need more power. And we need to be able to tell that to the Google endpoints in order to get more resources, right? And that is done through a bootstrapping technique that is generated by our Kubernetes cluster. So our Kubernetes cluster says more juice, and then we get more juice, and this is the way we get juice. So in this case, we are asking the metadata layer or the control plane of the cluster to give us the contents of the kube environment. And that is basically the certificate for our sort of cluster in order for us to sort of, spin up more resources. Fair enough, right? So we are able to download those. Do you think we can use them just straight away? Would that make sense? No, that is not doable, sorry. But then you come to think about it. Why are they even there then? Right? So if we are able to query these, why are they there? What are they used for? Anyone knows this? Show of hands. I won't stick you to it right now because this is sort of my talk. But if you know it, raise your hand. This is so sad. Yeah, okay. So they're there to bootstrap, of course, that's what we said, but we can't use them, right? So something is off. So we were able to download them, but our cluster says that we can't use this because it doesn't have permissions, because the certificate isn't right, probably, right? So then we can skip ahead, and then we can ask our cluster to help us create a certificate request based on the certificate that we already had, that we got from the cluster. Which is pretty cool if I do say so myself. And then it's like, okay, but could we use that one then? Nope. Why can't we use it? Because we don't have the private key, right? So we have only 2 parts of the threesome, basically, right? So we need the last part. But how does our cluster validate a PKI that lives in Google Cloud? How can that sort of validate the certificate chain? Can it do that? If so, could that be a breach of sort of privacy? Because then they sort of have our sort of certificate chain? Or is it just that they sort of trust certificates? So what if we do this? What if we do this? Will this work? So now we're actually signing this. We're just creating a new certificate with the certificate request thing that we just received, signing it, making it locally. And guess what? We're using the same service that we used before, putting it out to a file with the request file that we just created, and then boom. We're able to query the cluster, and we're able to get all the master nodes and all the secret shenanigans within the cluster. Pretty sweet. And guess what? This is native configuration. This is on by default in every Google Kubernetes cluster out there that has not enabled shielded nodes. Pretty cool, eh? So this is really bad, of course. Like now we're sort of impersonating a node, and the node is like the adult that runs all the pods, right? So now we sort of have access to basically everything that a node has access to by impersonation, which is really, really bad. And Google knows about this, and the action you have to take is that you have to enable shielded nodes within your console, or you have to ship a brand new cluster with the shielded nodes enabled by default. Otherwise, this is vulnerable today for node impersonation. Pretty cool. There is a bunch of tools in order to automate this whole process, but they doesn't really show what's going on in the background. But this is pretty nice. And this is not only valid for GCP, it's working on AWS EKS as well. Different endpoints, but the exact same gist. Okay, moving on. So now that we are a node, it will be awesome to become the actual GKE instance, the actual have a shell within the node, that the server running the node, right? That will be even cooler, isn't it? And then we have this guy, Duffy Kool-Aid, so created this amazing one-liner that spawns a privileged pod, basically, with an image of your choice, and then, spawn it as privileged. What can you do with a privileged node? Anyone? Exactly, you own the system. Like, this is not virtualization, it is a container. We're actually using a small pizza pie of an actual machine, and if we're a privileged pod, we're basically that machine. And then we can do stuff that we've seen below, but in the GKE clusters, or in the default configuration of the GKE cluster nodes, now the instances running your nodes, they don't have anything installed. So you have to start with, pulling maybe a package manager, or maybe BusyBox, or whatever, in order to sort of get something to work with. You know, we need to have our curl in order, right? So that you sort of have to install as well. But since you're root now, you can do that. So that won't be a problem. So then you can sort of download the utilities that you need using internet, and then patch the node itself in order to, query resources on that node. And in var lib, you can understand what's going on there. You can see all the overlays, you can see all the file systems, you can see everything that is mounted for the running infrastructure within your Kubernetes cluster. Everything. Pretty cool. Yeah. But we're not done yet. In addition to this, we have something called deployment frameworks. Anyone here heard about Helm? Cool. Are you using the Tiller service? No one? Or don't you want to dare to say that you're running the Tiller service? Nope. Okay. Good. The Tiller service should never be used anymore. This was a thing back in, I think it's 2 years ago. This was sort of announced. And you can basically do the same thing as the node impersonation, but you could do it in the app context instead. So you don't have to impersonate a node. You can do it for a deployment set as well, which makes sense, right? Because it has a unique name. It's bound to the same sort of certificate authority, the PKI, and whatnot. So it makes sense, right? It's not that bad. So in this case, you could impersonate the Helm and Tiller service, which is responsible for deploying stuff to the cluster. Guess what? Probably they have pretty high permissions to the Kubernetes cluster, right? Could be. So if you're able to impersonate the app deployment for Tiller, you then would be able to get the token for Tiller. And the token for Tiller will give you basically system administrative access to the entire cluster, which is pretty cool, in my opinion. I don't know about you guys, but I think it's pretty cool. So now we've pivoted a bit within both sort of the cluster, and we sort of broke out a little bit back and forth. But the thing is now, when we have this sort of plethora of nice things to run around with, we're able to break out to the GCP instances themselves. How am I doing for time? Pretty good, actually. Holy, that's good first. But there is more, of course. So the instance metadata, or the user data that is collected by resource verbs that has an instance basically in all the clouds, they have to be able to use some kind of ephemeral data set or storage object in order to get objects to ship to their configuration in order to make things go boom. And one thing that I've seen deploying in modern deployment pipeline is that you are using this in Bootstrap scripts or Cloud Init and whatnot all over the place, which is awesome and makes for a really good and coherent deployment process. But the problem is that we don't clean up after ourselves. So imagine you find a server-side request forgery as an EC2 instance. Are you able to read that instance user data then with the key that just leaked? Anyone think that's the case? Everyone is so nice and quiet. Yes, that is the case. You're able to read those. And guess what? They contain a lot of nice things. They could contain, like I did an assignment last week where the entire COPS manifest was present within the user data attribute with all the init hashes and everything. The entire sort of COPS's Kubernetes operations is like a template-based Kubernetes thing. If you're thinking about going the Kubernetes way and you Google around and it's like, oh shit, this Kubernetes thing is really hard, but COPS looks really nice, don't install COPS. Don't do it. It will just cost you more money because it is template-based and you will get a cluster that works for like 5 minutes and it's working, but then you will spend so much time trying to fix all the holes in it, so don't do it. Just start with something else. That was a side thing. But yeah, so the user data attributes are really nice, and if you're doing penetration tests within an AWS context or in Google, you should always query these. But then he's like, oh, Jesper, you don't know what you're talking about. They have 4,800 and gazillion user EC2 instances and whatnot. Fear you not. We made a bash script for this, of course. So we made this, this cool little one-liner that actually queries all the profiles, and that can take the profiles from an input file, and it will display it like this. Or you can put it out to a CSV or a JSON or anything. This is something really exotic you're witnessing here. Can anyone say why this is a bit vague to be in the user data attribute of EC2? Because this is what it is. Anyone knows why it's a bit weird? Come on. No? No one? It is a Windows command, right? That's not really common, is it? Is it? Are you? Okay, let's do this instead. Show of hands, how many are running EC2 instances, Windows EC2 instances? One. One. You see? It's exotic. Good on you, sir. Keep doing what you're doing. But this is pretty fun. So someone logs in, add themselves to the local administrative group. That's a good find, right? That's pretty cool. This is rarely the case. Like, this is not what's happening most of the time. But most of the time, I found really cool stuff like setting up a cluster, setting up environment variables, not using the secret manager instead, using it to bootstrap the environment that is spawned, right? So the problem that you should really clean this up after deployment. You should go in and scrape this so they aren't there. It's really important. And this bash one-liner will also be available after this talk. So it looks like this. So it will take the instances, basically, and it will use a profile that you sort of add. You can use whatever. And then it will take do the query against the API endpoint. It will decode the base64 blob. Because, yeah, user data are stored in base64 blobs, which is the best encryption schema out there, isn't it? So yeah, it's perfect. So yeah, and then it sort of spits everything else, and this could be used in different instance verbs as well. It has to be EC2. It's just everything that has a user data attribute. Cool. Yeah, so it's time for a recap again. You have been waiting so long for this. Basically, I have been waiting so long for this because now I get to show my cool map again, which is pretty cool. So what we did now is that we sort of basically abused the web horse. We used the web horse in order to ride into the city of the work village, basically, to sort of haggle us a ticket. So we were able to sort of cross the sea of unbreached clusters and get into the cluster and then beyond. And then beyond has to be the next talk, I think, basically. So yeah. The thing is, you should always know what you're deploying, otherwise things will go wrong. And if something sounds too easy, it probably is. And there is no excuse not knowing what you deployed, basically. So in order to summarize this a little bit more, security is hard. Kubernetes is harder. Cloud concept is really hard because it's changing every time. And it is sort of a moving thing that you sort of have to shoot on volley. But it will be very good to sort of define where your business starts and ends in the concept of where you put stuff. I am a firm believer that automation should happen everywhere. So in my opinion, I think it's feasible to do automates or sort of threat intel on your access logs, for example. If a web application starts to curl or do a reverse shell to a server that is owned by a security researcher, that should be something to look for, I guess. And that's really simple to add, like a really simple block rule or something. So egress filtering is basically what I'm saying in order not to be able to do exfiltration or create reverse shells. But in all honesty, I'm full of shit saying this, because everything that I've showed you now is queryable from the endpoints, right? So when we get the tokens, the Kubernetes tokens, we can query the public endpoints of it. Or if we get a security key for AWS, we can use that to query the API endpoints. So that has to be like, then you sort of have to have an ingress gateway in order. It's a long story. So it's not a linear thing, but I think it makes sense to look at your application logs and see what your application is doing. And if it's starting to do weird stuff, installing BusyBox on the node that you don't really are into because you're only using next, that is sort of a big thing. And I think that you should enforce and implement linters to your infrastructure code repositories in order to find obvious insecurity faults. Like, Terraform is really cool and it's really fast, but it's also template-based and everyone in here is lazy. Me also, of course. So we will use everything that works and it has to work fast and then we just skip it, right? So linter, that is a good thing. Think about the big picture. Everything is connected. Separation is key. Okay. And now we have an announcement. This is cool. Now we're stealing another conference. So the CFP for SecurityFest is open, and we want you guys to submit your talks there. Same thing that Skjortan did before here. I'm just doing this. Send your CFP here. We're changing venue, which is a world first announcement. No one knows it except you and internet now. So we're changing the venue to the city center of Gothenburg. So we'll be at Elite Park, which is smack in the avenue. Oh, you know. We will be there, and that will be a lot better because it will be take more people, and we will be able to do more cool stuff, which is cool. And that's about it. We made it to the end, guys. Yes. Yeah. And I'm basically on time as well, right? No one is angry. So any questions? We got one here. Do it. Should we use the mic? Yes, we should use the mic.
Hello?
It's on.
Okay, so if you do this as application as code versus deploying containers, which one you think is more likely to fuck up?
Both.
I mean, both?
Like everything that we build is I don't believe in the human race as something that is good on doing something like aligned with common practices, because we get bored and tired and do shenanigans all the time. So everything that is customly built is prone to break, basically. So it doesn't really matter in which context. We will find vulnerabilities in everything that we put our hands to, I guess.
Yeah. Thanks.
Anyone else? Don't be shy. Come on.
So I saw that the password was summer 2023 exclamation mark.
Yeah.
Was that the real password?
No, it wasn't the real password. It was actually a good password. It was a good password. I just had to do that in order to sort of, but it is pretty common. Like you should talk with Linus. He does this all the time. We have like a betting pool on how many % of a domain actually has this really shitty password. And you would be surprised. There is a bunch of them. Anyone else? Yeah, if you're shy to talk to me now, you can just find me later, I guess. No? No one else? I can't see any more hands. There we have one. One brave gentleman.
Hey there. Oh.
Yep.
So have you seen any good defense mechanism? Like there are like CNCF Falco, there are Calico for egress.
There's a bunch of nice things. I talked about with Franze, I tested a project that looked really cool, but I can't remember the name of it. I can look it up. This was so weird. I actually tested them, and I can't really remember their name. But they will be adopted to the CNCF, or the Cloud Native Computing Foundation, soon. The cool thing with that one is that they built their own repository for containers, basically. And how is that different from Docker Hub or Harbor and whatnot? Yeah, the difference is that they built context around their containers. So they get you a YAML configuration context, like a security context, that is hardened by default. So let's say they have a node image, and that has a bunch of hardening features attached to the YAML construct from the beginning. And then they have built native support for SBOMs and stuff, so you sort of can have a dependency validation form going with you as you deploy this and use this. So it's not a distroless container. That's what I said on the scoping meeting. Oh, this is like distroless containers, and they almost shot me. It's not like distroless containers. It's just like they have defined a security context for a specific build, which is pretty cool. So there is a bunch of initiatives. And like the whole Google node impersonations thing, you can actually, with a checker, remove this, and that won't be a possibility anymore with shielded nodes. Yep. Anyone else? No? Cool. I'm done.
Okay, thank you, Jesper.
Thanks.